everyone. Thank you so much for joining us today. And a big thank you for the OLake by DataZip team for hosting this session and bringing this community together. I'm Akshat. Currently, I'm a product manager at Cloudera, leading initiatives around our open data lakehouse offerings and actively contributing towards Apache Hive as well. So before transitioning into product, I've spent several years as a senior engineer in the big data space, working hands-on with and building data platforms using Hive, Spark, HBase, and whatnot, right? Designing and scaling data architecture across cloud and on-prem environment. So where we are today, right? So today, I'll just take you through the journey of demystifying lakehouse architectures, starting from the basics of what they are to the challenges that they aim to solve, and how they represent a natural evolution of modern data platforms. We'll be exploring the core components that makes up a lakehouse, from storage and compute layer to governance and interoperability, and then move into the hands-on scenarios to show how all of this comes together in a uh, practical world using Apache Iceberg. By the end of this talk, you should have a clear and practical understanding of how lakehouse architectures can be implemented in the real world and what to watch for when you're designing one in your own environment. So let's dive in. And as I mentioned before, so here's a roadmap of our session. So we'll start by setting the context with traditional data architectures. Then we'll understand why there is a need for this change and what the lakehouse model brings to the table. From there, we'll dig into the storage, compute, and governance layer. And finally, wrapping up with the hands-on, as I mentioned before. So let's go back in time, right? Traditionally, we used to have the operational databases, and that's where our data is generated by your applications, which were your OLTPs, right? And then there used to be separate data warehouses for your OLAPs. This introduced latencies, added data duplication, and complex ETL pipelines, right? Then comes the data lake, scalable but cheap, and but lacking structure, governance, and performance. To bridge this gap, many companies deploy a hybrid two-tier architecture using data lakes for their raw data and data warehouse for their curated data for analytics. But this too comes at a cost, right? Like data sync issues, rising cost, and poor agility. So that's that's where the tension is, right? Because business wants speed and flexibility, and IT wants control and governance. So we clearly needed something new, and that's where enters the lakehouse. But before we jump into what lakehouse is, let's understand what makes a modern data platform tick. uh, we know that data architecture is your blueprint, and it defines the data flow, access, lineage, interconnections, and the platform is what you build with it, a set of components working in harmony. So if you see on the diagram, it's mostly like covers 99.99% of all your data platforms when you talk about the architecture. And when you create your data platform, you just decide the technology to fit in these boxes, right? So you need your ingestions, you need your storage, your metadata management, compute engines, governance layer, and so on, right? And if you basically figure these out, that's a key to success, right? Basically, it's defining these interdependencies. For example, how your catalog integrates with your compute engines, and how access control policies flow through each layer of this architecture, right? And you also need guiding principle in terms of what should be the openness, the interoperability, security by design, and alignment with business goals ultimately, right? And if you get this right, you got yourself a scalable and future-proof foundation. So let's take a look at the current state of enterprise data platforms. And many organizations today operate using a two-tiered approach, as I mentioned before. So they have the data lake as their raw storage and data warehouse for their refined analytical workload. Some are experimenting with hybrid architectures or transactional system, analytic system, and modern cloud warehouses, which also now support semi-structured data and even real-time ingestions. But here's the issue. We always end up with a patchwork for specialized tools, which introduce data duplication, pipeline fragility, inconsistent governance, vendor lock-ins, and whatnot, right? Especially with rising prices. So you need a team just to glue it all together. And despite all this complexity, you still are limited with the reliability of how fast you can deliver this to your user, right? So this has led to a clear realization across the industry that we need a architectural pattern, one that simplifies, unifies, and scale. And so what exactly are we expecting from this next generation of platform? So first, it should support the variety of use cases, right? Support all data formats, be it tables, unstructured data, logs, and media. Second, it must serve diverse workloads for your BI tools, ad hoc queries, real-time processing, MLAI, and all your ETL that's already there. Third, it should ensure asset guarantee, governance, and security, just like a traditional warehouse. Fourth, it needs to offer a cost efficient and scalable storage native support. And finally, it should deliver high performance and should be easy to consume for the end user and reduce operational complexity. In short, we no longer are looking for trade-offs. We expect a single platform that is flexible, performant, governed, and cost-effective. And this is exactly where Lakehouse architecture comes into play and designed for ground up to meet these expectations while eliminating the legacy constraint of older designs, right? With that said, Lakehouse provide the best of both worlds. Even though it's a single architecture, it's not a really combination of both of them, but it combines those features from both of these world and bring the best of it, right? That gives you a unified storage with decoupled compute. So that's what it is. Now, diving into understanding the pieces of this architecture, the Lakehouse architecture, I've taken the reference from Cloudera Data Lakehouse. And these are overall all the components that you would see in any data lakehouse architecture. So starting from the bottom, you have your storage layer, right? Where your data can be stored in AWS S3, be it Azure, GCP. These are your cloud options. And if your data is on-prem, you have Azure, you have HDFS, you have MinIO, right? And on top of that, you have your open table formats, which can be Iceberg, Apache Hoodie, or Delta Lake. For Cloudera, we are all in with Iceberg. And if I can actually create one more layer between these two, would be your open table formats like Apache Avro, Parquet, and ORC. And above that, are your Lakehouse services, right? For us, it's replication and optimization, but there are many vendors out there today. OLake is also one of them, which provides Lakehouse services for your database to Iceberg migration. And on top of that, you have your unified security and governance that makes your life much easier, especially when you're dealing with compliances, right? We have a lot of customers who have this specific requirement because they're dealing with compliance system where they have to meet some compliance or build regulatory reports on top of the data. On top of that, you have your metadata management, which includes your REST catalog or metadata, which holds the hierarchy of your metadata. And on top of that, you have your all the data engineering activities, right? How you're consuming your data, how you're ingesting your data, all via your third-party query engines. So what Lakehouse architecture really does, it separates the storage from the compute. And that gives you your Lakehouse architecture, right? So moving on to, so I've put all the possible permutation combinations here, but we're not going to go through all of this, but just to brief out of this, right? So at this point, you must be wondering that if Lakehouse seems so idle, why didn't we always build platform this way? So this comparison helps you take a step back and look at the design trade-off behind each architecture. For example, data warehouses were built for performance and governance and idle for a structured data and BI tools, but they struggle with scale, flexibility, and cost. Now comes data lakes that flip that model, prioritizing scale, variety, and cost efficiencies. But in doing so, they give up on the things like asset guarantee and fine-grained access control. And then there is the two-tiered approach that I was talking about, the combined approach, right, which pairs data lakes and data warehouse. This tried to bridge the gap between those two, but added more complexity, duplication, governance challenges. Not just challenges, it was a nightmare, and often end up managing two different worlds in the same, right? But the Lakehouse instead asks a new question. Can we unify storage and serve all these workloads without sacrificing the consistency, performance, and openness? And thanks to open table formats like Iceberg and innovation around the metadata and compute, we are increasingly able to answer that question as yes. So this slide isn't just a comparison, it gives you a snapshot of how platform designs have evolved through specification. So most of this will be shared with you later, so you can go through each point and check for yourself. Moving on to individual components, right? So if you remember, I started with this. So keeping this in mind, we will go through each of these layers and talk about the design consideration. So when you're designing your own or you're implementing your own data lakehouse architecture in your environments, how you should go for it, right? So starting with the storage, this is the center of all of this, right? What really makes or breaks a lake house, it's the storage layer. So let's take a closer look of what powers it what powers it underneath, right? So before we get into this, there are some key concepts that most of us are already aware, but sometimes when we are implementing this, these things are forgotten, right? which is your which is your storage, where your storage start basically. So columnar formats like Parquet or ORC enables analytics workload by storing data efficiently and enable fast scans compared to your row based formats like Avro. Column based storage allows skipping irrelevant data and compressing similar types more effectively. And Lakehouse also relies on partition pruning, clustering, and stats to reduce data scanning and speed up your query. This is one of the reasons why they perform so well, right? And when you're designing your overall lakehouse or any data architecture, these are the things that you need to focus on, which is the use case, right? What are your end user and how you want to support them. Is your use case more ingestion heavy? I'll go through that in a bit, so let me take it up there. So for now, let's understand what the lakehouse storage components are. So if I have to break down the lakehouse storage component, it involves the actual storage. It can be on your cloud. For that, we have AWS S3, ADSL by Azure, GCS by Google, GCP for on-prem, as I mentioned, you have HDFS, Ozone, and Menio. And on top of that, you have your open file formats, the Parquet, Avro, ORC, and finally, the open table format, which can be Apache-Iceberg, Apache Hoodie, and Data Lake. So with that said, when it comes to building a lake house, one of the most critical choice is your table format, because that's what brings asset guarantee, schema evolution, and time travel to your storage layer. The three leading open table format today are, as we all know, Iceberg, Hoodie, and Data Lake. And each one of these bring different strength based on your use case and ecosystem preference. So let's start with Apache Iceberg, which is the foundation of even Cloudera's Lakehouse architecture and OLakes as well, right? That's the primary use case. So Iceberg is engine agnostic, supports partition evolution, schema evolution, time travel, and is known for clear separation of metadata and data files. It supports Parquet, ORC, and Avro, all of them, and integrates deeply with different platforms like Cloudera, AWS, GCP, Snowflakes, and more and more. On the other hand, Apache Hoodie is optimized for incremental processing and write-heavy workloads. It supports ACID and time travel and is often preferred in streaming-heavy pipelines, especially in AWS-first environments. However, it lacks features like partition evolution or native support for Avro. So, and then there is Delta Lake, which is tightly coupled with Spark ecosystem and popular on Azure and Databricks, as they are the origin creator for that. It brings advanced features like cloning and Z-ordering, but it only supports Parquet and works best when you're fully within that ecosystem. So if you recently attended the Iceberg Summit, even Iceberg Future, given the tabular acquisition, now they're bringing, so they're closing the gap between Iceberg and Delta Lake, so there's better interoperability. So the takeaway is that there's no one size fit for all, but all enterprises are looking for is openness and multi-engine compatibility and robust schema management. And Iceberg has emerged as a strong standard for production grade lakehouse deployment, and hence you see Cloudera also primarily focusing on Iceberg. So with that, now that we understand table formats, let's zoom in one layer deeper uh, to the file format themselves. So these are physical representation of your data on disk, and they play a huge role in performance, compression, and integration with your compute engines. The three most widely used formats, formats, I would say, are Parquet, ORC, and Avro. While Parquet is the most popular for analytical workload, it's a columnar format, which means queries can scan only the columns they need, reducing the I/O operations, and it also compresses data more efficiently and is widely supported across tools like Spark, Trino, Hive, and most of the query engines today. It offers the default choice for most analytical pipeline. And when we talk about ORC, it's also a columnar format, and it shines in Hive ecosystem. It offers strong compression and supports asset compatibility natively in Hive. So Hive Asset, if you want to use Hive Asset, you're probably using ORC, which makes it useful for traditional data warehouse styles workload on the data lake. On the other hand, Avro is a row-based format, which makes it ideal for write-heavy or streaming scenarios, such as Kafka pipeline. It compacts and supports schema evolution and is widely used in messaging serialization. But it's not very optimized for your analytical queries, since it can't take advantage of column-level pruning. So the choice depends on your workload. If I boil it down, right? For analytics and BI, columnar format like Parquet or ORC are the way to go. For real-time ingestion or message-based systems, Avro still holds its place. For Lakehouse storage layer, often uses these mix formats, but understanding the strength help you take the right decision for performance, compression, and compatibility. So choose based on your end user and keeping them in mind, right, and your overall requirement. So with that said, um, Lakehouse storage brings a lot of flexibility. But when you're designing your own lakehouse, what are the key considerations that you should have, right? Always consider the ecosystem support. So every one of these projects have their own ecosystem. Some vendors might be you might be either getting an enterprise support, or even if you're building yourself, you need to think of the ecosystem, right? You need to think about the community support. How many contributors are there? How active the project is. We need to think about the maturity of the community, how old or new the community is, the commercial backing behind a particular tool. For example, Iceberg. Currently, Iceberg has the most commercial backing. If you see, there are many companies contributing to Iceberg and putting their money on Iceberg, if I may say. Then comes the benchmarking data, which gives you an idea of an actual comparison on performance, which is very important. And you always need to think ahead, right? How will you design your scale for next 2 years, and will it support new workloads or real-time analytics at that time? So keeping that in mind, choose your table formats or your file formats accordingly. Now, talking about the compute, which is basically the brain of your lakehouse. Lakehouse supports decoupled compute, as I mentioned, right? If I talk about a data platform, you have data engineering activities, which can be either data ingestion, processing on top of your storage, plus your open table formats. And then finally, your data consumption activities, which can be your BI tools, which I mentioned also, right? So you can use Spark for batch and ML, Flink for streaming, Trino for ad hoc. So with Lakehouse, you get all these benefits, which enables you to choose the engine for the use case, right? It gives you the freedom to choose different engines for use case, and also provides you cross zone, cross region, cross account access, because now your storage is decoupled with your compute. So you can individually scale or independently scale your compute. So those are the benefits that Lakehouse architecture brings to your compute as well. Now, talking about the data governance, this is one of the strongest differentiator in Lakehouse or in general data architectures. You always need lineage, how your data is evolving over time, how your data is traveling. You need to audit those. You need access control and schema validation. You need metadata management. So these are some of the data governance and security exercises that you need to keep in mind while you are choosing the right tech. So many a times, for example, in Cloudera's data architecture, you saw a layer which is SDX, right? So for us, SDX ensures that governance policies apply across all engines and dataset. Similarly, it starts at your catalog level, right? Because that's the entry point or meta store where your engines are interacting with your data and getting that metadata to access your overall data. So you need to think about these use cases while you're designing your lakehouse. Now, finally, putting all of this together and thinking about what are the activities that you need to do while you're designing or implementing a lakehouse platform, right? So if I boil it down to very simple terms, right? How do you get started? First, understand your requirement. Understand the end user requirement, because many times data platforms are engineering driven rather than end user driven. So what happens is we end up using the best tools, best of the best, or the latest and greatest. But when it comes to serving the end use case, we often face issues, right? So understanding your platform requirements is key to building a better usable platform, because more often than not, your data platforms are not just used by one team but various. So keeping the personas in mind, keeping the tools, the end or downstream tools in mind, you need to build based on that. Study the existing system. So before, let's say if you already are using some sort of two-tiered architecture, data lake architecture, or data warehouse architecture, you need to understand the existing system and what really what value really does Lakehouse architecture or open table formats like Iceberg brings to the table. Like if the use case really is for to you to use snapshot based time travel, or manage table, or even control replication, then yeah, go for it. So understanding your existing system and where the uh, key gaps are is very important, and overall understanding the vision and data strategy for the coming years is very important. And most important is communication, right? Communicating with your end users is very important, because in the end you can build the best data platform, but if it's not usable by the end user, it does not gives the end user the data they need at the time they need, it hinders the product growth, right? Or the decision making in general. You need to establish your guiding principles. What are the key factors that you want to consider while you're building this, right? Whether it's what's the data ecosystem, what should be the scalability and performance, what are your cost control measures and your optimization measures, what is your platform operations, what are the operations that you perform on this platform, the governance and security, right? So with these things, so individually, actually, there can be just another session on individually these things, but this is just a high level to give you a high level understanding on what are the steps that you should take. With that in mind, and making sure that we have enough time to understand how this works, right? I'm trying to give you a demo scenario, right? So there are three quick examples that shows you how these things happen when you actually implement these pattern, and what is the difference, the actual ground level difference, when we talk about a data lake, traditional data warehouse, and lakehouse solutions, right? When it comes to boils down to query, how your data is behaving, what are the features that are lacking when you're performing these query. So I have three scenarios that I would like to show you, so you can also try these out. So a great example is an open source project, Gravity. So that's a catalog basically. They have their own playground, and there are actually more open source projects that give you a overall Dockerized setup, so you don't have to install every component locally. For example, if you remember the architecture, right? Let me go back on this and open the architecture again. So to set up in your local, you need to have all of this set up, right? But it's much easier if you have everything Dockerized, and there are a lot of projects in the open source community that you can use, which have already Dockerized these things. One of the examples that I'm using or have tried is the Gravity Playground. There are a few more which I can actually maybe later tag on Slack. So imagine running a query, right, which is just your raw Parquet files in a data lake, which is just storing your data into data lake. So what are the limitations? So when you try to write the data, all is fine. But when you try to update it, it will fail, and it will require a full rewrite of that data. And that's the limitation, right? It does not have ACID. It does not give you any time travel. So why time travel is also important, we should talk about it, is because imagine you're running a workload on a regular basis, on a daily basis, and due to some errorless data that's coming from your ingestion pipeline, the entire data pipeline is now screwed, or there is some data issue. Time travel really enables you to go back in time before you ran the pipeline and fix the issue, and then run the pipeline. So your ultimately downstream workloads or your BI tools or decision making reports does not get affected, right? So with the current data lake format, you can't do that. Let's talk about data warehouses. Let's assume that you have created a data warehouse on top of this data. And when you try to alter the table or do all of those things, it blocks you, right? Because first of all, it's slow because now you have to load the data into another um, data warehouse. Many a times it has a lot of proprietary formats. So for example, if you're using Teradata, right, they have their own proprietary syntaxes, which will not enable you to use any query engine that you want. So for example, if you're using Hive tables, and generally Hive tables is supported by most of the engines, right? Be it Hive itself, be it Spark, be it Reno. But if you're using, for example, any proprietary vendor query, you will not be able to use multiple engines that supports the best for your use case, right? So that's a limitation of using data warehouse. Now talking a scenario where you're using iceberg backed Lakehouse. So you end up creating table using an external location. You have native support for update and delete, which means you have asset compliance. You can change the schema as you go. So you do not have to completely rewrite your data. You just change your schema. And because of Iceberg's snapshot based metadata management, all your new data will be partitioned or schema have been applied on the new data. You don't have to completely rewrite your data. Then you have time travel. So some of the example of time travel queries is, as I mentioned, time stamp as of, and even version control and rollback. You can say you have version as of syntax. So this gives you asset transaction, which makes it open. It has schema and partition evolution. It gives you time travel feature. It has multi-engine access because most of the latest and greatest query engines support Iceberg natively. And the cost and vendor lock-in is still low because all your data is still in the same storage. You are not moving that data and creating multiple data copies in your data warehouses. So these are the scenarios that you would like to try. And if you really want to try, you can have this set up in your local with just one script. And there are other tools also. And if you go through this, there are many query examples beyond what I've added in the slides that you can try out in various examples. So there are many notebooks as well, right here, and there are many projects out there which I can link maybe after the session as well. With that said, if you really want to try out enterprise grade solution, you can also try a trial for 5 days of Cloudera, which gives you access to all the engines. So you don't have to do the setup at all. You can just log in and try out how the Lakehouse architecture and what queries you can actually perform on Lakehouse beyond what you can do on a data lake or data warehouse. So with that, I think we are at top of the hour, and I would really like to thank you for being the part of the session. And I hope this helped clarify what Lakehouse architecture really is and how they can help your data strategy. And if you have any questions, feel free to connect me on LinkedIn or drop a message after the webinar. So I'd love to learn more about your use case if you have any. So yeah, I think we make good time, hopefully.
Absolutely, absolutely. Thank you so much, Akshat. It was really insightful for me. And guys, please let us know, like, if any questions are there or if any follow up, you would want from Akshat on any sort of topic that he just spoke on. In the meantime, I have a bunch of questions which I have written. Uh, but yes, we will just take Ajay's question first, and then we'll just hop on to the questions as well.
Sure. So
So Ajay here asks how the isolation level works in Iceberg and what to use when.
The way so again, we have to go deeper into the architecture of Iceberg then. Uh, I'm not sure if we have time, but what the way the isolation works in Iceberg is based on their snapshotting mechanism, right? So let me see if I can just pull up a diagram of Iceberg architecture, and that will help in explaining this question better. So yeah, let me share my screen again. Okay. So basically, it's all enabled by the metadata layer of how Iceberg works. So Iceberg basically has three layers, if I may. One is your catalog layer, one is your metadata layer, and one is your actual data layer, how the data files are stored. And the way Iceberg really isolates your schema, or even write or read, is by creating a new snapshot every time there's a change or an operation on the table. So if you see, the data files are same, but every time you make a operation, let's say if you're inserting the data or updating any column, or doing schema evolution or partition evolution, it creates a new snapshot which is linked to its manifest list, and then manifest files, right? So again, there can be just a session on this topic, but just to answer your question in brief, the way it does it is by creating new snapshots, and making sure that you have access to the latest snapshots. And yeah, that also introduced the problem of table maintenance, that you have to constant making sure that you're deleting these unused snapshots or older snapshots of the table in timely manner. So that's another topic for discussion. But yeah, hopefully I answered your question.
Via such questions, you just find so many different topics that you can conduct webinar on.
Yeah.
And I'm loving this, honestly.
So it's not this typing. Hopefully
uh,
as a follow-up. Okay.
yeah, absolutely. So we are up with the next question, which is asked by Harish.
Okay.
What kind of open source tools available for enterprises to migrate data from Oracle databases to open storage formats like Parquet?
So I don't know of any open source tool that are available to migrate data. So I think it's more on. So Harsha, do you want to take it? Like, does OLake supports it? Because I know OLake supports from database to Iceberg. I'm not sure if they also convert it to Parquet. So would you like to answer this, or someone from OLake team if they support it?
Yeah, absolutely. Shubham, are you there to answer this? Yes, Shubham is typing. So he will be the best person to actually say this. And yes, OLake support storage formats like Parquet, and then we dump it to Iceberg as I'm also known. And Oracle DB is in roadmap. Right now we support MongoDB, Postgres, and MySQL, and next we are up to doing Oracle as well.
Okay.
Harish, feel free to check us out.
Learn practice. So Ajay also asked a question. One more, which is good material to learn practical or experiment Iceberg. So there are many. So the good thing about Iceberg is getting a lot of traction. So frankly, it has more traction than it has adoption. So you can find a lot of materials online. There is the Iceberg documentation is actually pretty good. If you really want to, you're really into reading the official documentation. Iceberg documentation is really good. It's quite up to date, even with versioning. So Iceberg, what really is a spec, right? You need an engine to actually implement those features. So you can choose one of your favorite engines. As I mentioned, that it's engine agnostic. You can use Spark, you can use Trino, you can use Hive. All of them have great support for Iceberg. So yeah.
Sure. Okay. Next question that I have from you. Just a second. Yeah. What are the key design decisions when choosing between different metadata catalog implementations, Hive, AWS Glue, Nessie for Lakehouse architecture?
Yeah, again, a great question. So so I'm a PM for HMS also, so and also contributor in Hive. So I'll so even though the industry has a lot of things to say about HMS still backing or powering most of our enterprise backend enterprise metastore service, right? So HMS is by default very prominent in adoption. And the key design considerations I would say that you should take care about is very dependent on your use case. For example, a lot of enterprises have policies like they want to implement HA, right? If so they end up implementing HA on their underlying RDBMS, and then they implement HA on their Hive Metastore also. If you're into if you're using, for example, S3 tables, right? Right now, the only way that you can do is using AWS Glue. Nessie is more of, so when Nessie started, it started as a Git-like tool for data. You can commit, you can create a branch from your data. So it all boils down to what your use case really is. All are very efficient at what they do. All of them has their pros and cons, but it again boils down to what your really use case is. If your use case is S3 tables, go for AWS Glue. HMS is still the backbone of majority of meta stores out there, and that we're using. Nessie, there is still work going on, but when it started, it was mostly on Git-like structure on your data, right? So if that's your use case, go for it. But yeah, those are the considerations that I would say you should take, understanding the use case very well.
Thank you. The next question would be, yeah, this is an interesting question, which I'm very curious to know your answer on. So, given your work with multiple table formats, and I know you are an advocate for open source formats as well. So, do you believe Apache Iceberg will become the dominant standard, or
Oh,
will
it has
we
already
see
become.
continued?
It has already
Yeah.
become the dominant standard in the industry. If you see the traction for Iceberg
Yeah.
or even Lakehouse architecture, right? As I mentioned, that is still new in compared to the traditional data architectures for all data platforms. And given majority of large enterprises, it's difficult to migrate very quickly, right? So
Hmm.
there have been a lot of surveys out there. One is even Cloudera has conducted one survey. There is surveys by Dremio. There are surveys by n number of companies. There's surveys by Gartner as well. So all of them have talked to all the Fortune 400, 500 companies, and if the question for them was, um, have you started adopting Lakehouse architecture? If
Mhm.
not, in next 3 years, which table format you would use? And more often than not, the majority have answered as Iceberg. Given the traction it has, given the community support it has. If you see, um, India is still growing on Iceberg, to be very frank. But if you see in US or other countries, Iceberg meetups are very prominent. The
Yeah.
community is very active in Iceberg. So yeah, if I talk from a community perspective, Iceberg has a lot of traction. You can ask any question. There will be someone to respond to you in the open source as well.
Yeah. Absolutely. Okay. In your experience, what's the biggest misconception data engineers have about Lakehouse architecture implementation?
Okay, so this is something even I had when I started. So, um,
Yes.
I had to read a lot of research paper, and one of the research paper was written by the original founders, right? Like Databricks actually came up
Right.
with the Delta Lake, and that's the research paper where it started. So
Mhm.
the biggest misconception is always that. So the whole reason why someone would use Iceberg or Lakehouse architecture is to reduce data duplication or data movement and make sure that you get direct access to your storage, right, with the catalog. Now, many times people are still confusing it with creating a new data warehouse. So what they're doing is they're still using the two-tier architecture, creating Iceberg tables, and on top of that, they're also creating a data warehouse and calling it Lakehouse architecture. So that was a misconception that I also had. But yeah, with time, it goes away.
Okay. So we
Not sure
have
if
two
that
new
was
questions
clean. It
until
was,
my.
sorry, so go ahead. Yeah.
So sorry. Please continue.
I was just saying that I'm not sure whether that was just a dumb misconception that I had or many people have it, but I definitely had it for sure.
I mean, we can have this in our live chat as well. If people had this misconception or any of the misconceptions you guys previously had as well. But yes, meanwhile, if this is coming, we have two new questions. One is from Shubham. What are the good compaction table optimization strategies or any tools you are aware?
So, like I can talk from what we also provide, right? So, we have a tool called Cloudera Lakehouse Optimizer. It's currently in TP. What it helps you to automate the process. You define the policies on your table, and it will, in the background, check the if that policies met on the table and perform those table optimization and compactions, right? It can perform your snapshot expiry, your orphan file deletion, perform your compactions, all of it. So there are multiple tools that are getting out there. All catalogs are also implementing one way or the other for the same purpose. But yeah, as I mentioned earlier, right? Lakehouse is still relatively new. There are the tool. There are a lot of tools out there that are coming up recently. I think there is Lakesphere also. I think Lakekeeper is also implementing some optimization, and there are just a lot of tools. But honestly, I don't think there's a enterprise grade tool out there which is completely G8 today. I might be misinformed on that, but there are still tools coming, and you will see a lot of innovations this year in this space. But for now, the easiest way to do it is by running Spark procedures, which are documented on the Apache-iceberg documentation as well. You can run manually if you want to automate it. Many customers I've seen using Airflow or tools, automation tools, do that job themselves, yeah, without using any tools. Out there.
That's great. Shubham, you can also write down if you have something to add on here as well. Would love to know your take on that as well. Okay, next question from Mayank. How is lineage captured, especially in scenarios when few computes APIs is outside Lakehouse?
Interesting one. So how is lineage cap? So lineage are generally changes in your metadata, right? So it's your catalog is really responsible for that. When you're or the tools that you're implementing on your security and governance layer, that's where you need to make sure that these things are not going beyond the scope of basically there's no direct access to your data. Everything is going through that unified governance and security layer to make sure that the lineage is built. So you need to ensure that the security and governance is in place.
Hope that is answered, Mayank. Okay, next question by Harish. Any good practice on migration strategies to open storage formats?
Oh, definitely. So I recently also uh, took a session in the Apache Summit that exactly talks about the migration strategy, specifically talking about Hive to Iceberg migration. So if you're interested, I can link the whole talk in the comments later or in Slack. So we covered even how you should think about it, or a decision tree in the end of that session, which you can refer to when you're planning your migration as well. So hopefully that will help.
Absolutely. You can link yours as well. And we also did a webinar, previous webinar on the exact topic.
Oh,
It was done.
let's let's flood the resources. As I said,
Abs-
Facebook has a lot of resources out there, so you won't. So there's nothing unique, I would say. So you can just see and find which suits your understanding best.
yeah. Harish, I will just give you the link as well of Slack. I was about to put that uh, by the end of the session, but yes, I have done that right now. Ajay asks another question. Please, can you share some thoughts around challenges using Iceberg with respect to performance and scalability?
So as I mentioned before, that iceberg is a managed table, right? So you need so as your data grow, the if you saw the architecture, right, the number of snapshots, the orphan files, the older metadata files keep on growing if not tackled properly. So performing table optimization, compaction is very essential with iceberg. So if it's not done timely, or you organize or plan your compaction activity or query or optimization activities in time, you will face your query slowness, right? It also there are many configuration level things as well. For example, target file size, right? So if you end up so iceberg by default are great, right? So iceberg if you're using Iceberg and using Iceberg default configurations, you're in good hands, right? But if you're modifying those defaults, I would suggest that make sure that you understand those configurations, because we have seen people changing those configurations and then facing performance issues. So sticking to the default should be fine, but yeah, so those are the some things that can cause performance issues or query slowness overall. Iceberg is very known issue is small file problem, right? When you have very small files, all the read on the engine level or query planning level becomes a little expensive, and if so, it has to traverse all the files, right? So it's better to compact and plan your compaction and query optimization, table optimization task very when you're designing these. So I think, yeah, we should add that in the design and implementation to plan your optimization strategy while you're designing your lake house as well, especially with Iceberg. Yeah.
Okay. Hope that answered your question, Ajay. And I will put down the conclusion question that I have. And I mostly ask all my speakers for advice. And since like when we connected also, we were talking about like, how the contributions are increasing in OS projects, and how much like, Indian contributors are also like, showing their participation around, right? So we have also like, people joining in who wants to contribute further and who wants to make their names in OS projects. So what advice would you give to those data engineers?
So I'll just talk about my journey. This is very personal. So uh, when I became a data engineer, I started learning Hive, Spark, and all those tools. One thing, so this is only when I joined Cloudera, I got the opportunity to actually contribute to Apache Hive. So I was always a user of Apache Hive, but never a contributor. So when I started, it was very difficult uh, to just understand where to contribute, because if you see, the code base itself is very vast, so you never know, okay, which part of the code I should contribute to which. So good thing is that the community out there is very friendly. In any open source project that at least I've worked on, community is very friendly, even for Iceberg, even for Hive. uh, it's always about reaching out to the right people, asking the right questions. So if you don't want to do that also, then I would suggest every project has so you can go to the issues. If the project follows the Jira process, you can go to the Jira, and there would be a tag called good first issues. So you can pick those will also have descriptions. It will have comments from the committers or the PMC members of that project to guide you to how you can start contributing to that particular code base. And I would suggest, whatever project you're choosing, make sure that you have a good understanding of the tech stack of that. For example, if you're contributing to Hive, then I would say one thing that is a necessity is understanding Java, right? If you have good understanding of that, picking up a good first issue would be very easy. You can always reach out to community pages, right? For example, OLake has Slack. All Apache Foundation projects have their dev list, they have their user list that you can subscribe to and post your questions. For example, if you want to pick up some Jira, I think the best is to just comment on the Jira that you would like to pick it up, or you need some guidance. There will be someone who will definitely help you out. So yeah, that's how I started. I reached out to people. Luckily, there were a lot around me, so they just helped me out. So yeah, reach out to people. So the community is very important in any open source project.
Yeah, I feel it is like, very important in every aspect these days. And so many people are out there to help you out, to help each other out, to like, grow, to learn from various aspects as well. So yes, I have also put like, the GitHub link of us. Like if you would want to start your contribution journey, like, let's get you started. It's also an open source, and we are aiming to be the fastest replication of database into data lakehouse. And you can just join us in our very beginning journey, I would say.
Yeah,
So
new
yes,
projects
I
are always
think,
to contribute to.
yeah, absolutely. I think I am done here. But yes, like, is there anything that you would want to add,
No, I think I
Akshat?
really had fun meeting everyone. So yeah, thank you for having me, and hope you guys keep on doing great webinars.
Absolutely. Thank you so much, Akshat, for